Hi, yeah, I'm Nigel from XML. I'm here with my colleague, my boss, Robin, who's hiding over there in the corner. What we'd like to do is we'd like to talk a little bit about some of the issues we find when we're comparing XML. So I'll talk a little bit about our company, introduce ourselves, and then we'll get on to the talk. We're a software company based in Worcestershire. There's 10 of us, about 6 of us are Java and XSL2 developers, and that's how we develop most of our products. We have a history in XML and in comparison, and it started in about 2001, 2002 time frame. We've moved on from kind of a comparison engine that used to read 2 files, produce a comparison result, and we gave it to people and they could figure out what they wanted to do with it with JAX-P, to providing more infrastructure, more layers around that. So, for example, we provide samples of different kinds of change processing, handling different kinds of data. More recently, we've been developing some format-specific kind of black box products which are pre-packaged to make comparing certain kinds of documents easier. And those currently support document formats like DocBook and Ditter. But I'd say we are probably an equally XML document company as well as an XML data company. So we see both kinds of XML being discussing today. So those are kind of some of the things we do. We do a lot of customer support. And so our customers will say, we've got this document format. They come to us and say, we'd like to do some kind of change processing, get a result, process it to produce this. And we say then, what is your document format? We look at it. So in the process of doing that support, we see a lot of different kinds of XML. And I say, mixture of documents and data. So in that process, we see a lot of things we say, oh, why on earth did they do that? That's an atrocious way of doing that in a schema or a DTD. Couldn't they have done it better? And so we kind of thought about writing it down. It's something we've been meaning to do for quite a few years, is to say, right, let's describe some of the issues we find all of the time in the data we see that people are trying to compare. And so the new conference, we've been meaning to do it. We thought, can we write a paper? Let's do this. So we hope that the audience here is a mixture. We didn't know who to expect, who would come. So we hope there's some developers. And we're kind of in the middle of that Venn diagram that Ron described. So we hope we imagine some of those people as well as some people either side. There's part of the presentation is kind of aimed at schema designers, information architects, how to design a DTD, how to design a schema to get good comparison results from it. And it's also addressed to the users, authors, and developers. So I'll try and talk in fairly general terms. Although I can speak authoritatively on what our software does and our algorithms, I think this is going to be a fairly generally applicable talk. So I think some of the algorithm issues equally apply to things like Unix diff or the kind of version control that you'll find in software version control systems like Subversion, QRealKit, etc. And it's applicable to XML processing more generally. So let me move on. I've tried to distill a presentation out of about 8 or 9 topics I actually wrote in the paper. So I tried this out during the week and discovered I tried it and I got about 40 minutes and said, okay, you need to cut some of these down. So I'm going to present to you 4 of the topics in a bit of detail. There's more information in the paper, so there's discussion of things like XML Lang, data typing, processing instructions and comments, which I'm not going to cover in the presentation. Okay, so we'll move on to the first discussion, which is talking about white space. And I think it's fair to say that we see more white space issues when we see XML data than we do when we see documents. And we think that's probably because there are a few widely established document formats out there. We've heard of Ditter already, we've heard of DocBook, and people tend to adapt, extend, subset, specialise those kind of formats to suit their needs. They don't really invent new documentation formats, and so when they go through that process, they'll be they'll also be adapting the DTDs, the schemas, and the things that go with them. So the white space issues most commonly occur with data, and we often kind of talk to customers and we'll find that they say, we don't need a DTD, we're communicating privately from this. Two people are reading and writing the same stuff, they're writing the code to do it, we don't need a DTD to do that, it's a private communication. And then say, well, you just invited us into your private world, and so we're now kind of involved in that, and we begin to see the problems. So, we do have options to strip out white space. So you can set a command line flag that will remove the white space. But that requires user intervention, it makes it harder to use things, use standard XML tools, and we can't do it as well as a parser. So let's just look at the obvious example. So this is just an example of a data format, and you'll see it's a contact record, and you have a phone record with 3 sub-elements, 3 child elements in it, and you say, what's the problem with that? Well, if without a DTD schema or anything, what that phone record actually contains is 7 or 8 children, because you've got 3 child elements, you've also got 4 chunks of white space and line feed, 4 spaces in front of each of those XML records. That is the sort of data we're kind of faced with. Now, when we compare that, that has a cost. We don't use a DOM, you'd be happy to know. We load it into a kind of internal array-based data structure, but each of those nodes in the tree occupies space, and so that sometimes occupies twice as much space than something that either had a DTD or didn't have that white space. So there's a cost in that. Cost in, obviously, in terms of the file size, in terms of the Java heap space you need to represent that internal node tree. And we need to process those things. We don't know what that white space is until we actually look at it. So we need to load it into the node tree, we need to start comparing it. So comparison algorithms are going to be, good ones tend to be order n. So what you're doing is you're doubling n there. So your comparison with the white space is probably going to take twice as long as the comparison without the white space. So these are the kind of that's the kind of worst case scenario. You've probably got 30% there in terms of increase in space and processing time. So that's a feel of kind of the data. We often see this, and we'd like to get people to put a doc type at the top. It makes it easier for us to handle. So that's the simple solution. There's a pathological case we have with white space, which I'll try and describe a little bit later if we have time. But you can have cases where you have one input of a comparison with white space, one without, and your comparison performance goes to n squared. So I've got time later, I'll come back to this and describe why that happens in terms of the actual algorithms that are being used. But for the moment, I'll kind of summarise the white space one and say, please use the DTD, and also please relate it to your instance files. So doc type statements, schema instance, namespace attributes, put them in. Relax ng, a little bit harder. There's a document model processing instruction you could use. And there's this kind of debate about whether there should be that instance relationship between your schema, your DTD, and your instance files. We're in the general XML tool world, and we are believers that that kind of relationship should exist. Finally, a little word about XML space. It's mentioned in the XML spec. It isn't really about parsing, so it's more to do with passing information to the receiving application. So the DTD's grammars are about differentiating between element-only content, mixed content, those issues. XML space is kind of an instruction. It's saying, this is hands off this element, hands off this white space. And so when we don't have a DTD, we turn on our flag to say, strip the white space. We won't strip it with XML space, and editors will change their indentation behaviour, other things. So you see it on things like pre-code block. Please use it, because it does have its uses. Okay. So let's move on to the next one. Staying on the kind of data side of XML, we often have people who give us data and talk about ordered data, unordered data. And so to handle that, we let me step back a bit. Documents, I think, are usually ordered. The presentation of them, when you produce a PDF file or whatever, you expect a certain ordering. People will complain if you mix the chapters up, if you put things out in the wrong order. And that includes things like even the metadata, which has a presentational aspect. If you feed it through something, you generally want to see it in the same order, and people get upset. But it even comes down to things like UL. You think you could reorder the UL, but no, people just like them because of bullets instead of numbers. So we kind of have documents are usually ordered, but data, we often have a request to say, okay, my data is a set. It really is, there's no order, it's a database dump, it's dumped from this system and it changes how it does it depending on the day of the week. So we have both kind of requirements. We have different algorithms to address those requirements, but we have a problem when we see things that look like this. So here's another kind of contact record, and this is similar to an example we saw a few years ago from the Inland Revenue. So they had, I think it was corporation tax returns, that was something like this. So they had parts of the data, there was definite ordering. The postman would have problems if you rearranged people's addresses. But the software that was generating this stuff tended to put phone numbers out in arbitrary orders. And they didn't want to know about the changing ordering of phone numbers, but they did want to know when the address changed in any way. So we have kind of two different requirements within the same set of siblings there. And our advice in kind of this scenario is not to do that. Okay? It's to introduce a little bit of hierarchy to avoid the problem. We can then attach one of our attributes to it, which will cause the comparator to do a different algorithm on that data. So and I think there are kind of other places where this technique is useful too. So if you imagine you do a XSL sort, XSL for each group, it's nice to have the data you're sorting, the data you're grouping contained within the same type of information. So we'd recommend to certainly differentiate between your ordered and your unordered data by adding hierarchy. Okay, so I think I've said most of that. The final thing I'd like to say is we often see a DTD or a schema file and you see the repetition operator, the star, the plus, and that tells you can have many of the things. What it doesn't convey is the orderlessness of the data, whether the developer considers it to be a set of things or a list of things. And there isn't because parsers are about automata and the schema languages have been developed in order to support them, they don't really have that concept either. So what we'd say to people is please document your expectations for the ordering of your data. We often first we learn about it, we get documentation, we get reference manuals, we get DTDs, but we only learn this through kind of support information. Okay, I'll quickly talk on representing change. So we have ways of representing change in our tool. It's called W2. And it's a generic way. It handles well-formed XML. It adds attributes in a namespace which you can process in various ways to do things. There are other ways of representing change generically as well, and a lot of XML editors use processing instructions. Oxygen uses processing instructions to track what the user does and describes things in additions and deletions. There's a W3C community group which is looking at ways of improving that and increasing the range of that mechanism. And when that happens, we can use it to represent comparison, as well as the editors using it to record change. And a good example of that, for example, is Word. In Word, you can use the track change mechanism when you do compare. It also uses that mechanism to describe the results. And we can do a similar thing generically with XML. I want to move on to the language-specific stuff. So, certain languages have different ways of representing change, and I've given a few examples there. Status of rev editor, revision flagging, book, and using del in HTML. We like using those because it allows us to reuse the software we've heard about earlier, Data Local Toolkit. There's also .book XSL. If we can represent the changes using them, we can use standard software to show the results of comparison to people. So here's a few examples. This is ditter, and it has an attribute called status. So when we detect something's been added, we can add that attribute to, for example, a paragraph element. If it's a finer grained change, such as inside a chunk of text, we can introduce a PH element for phrase and use the status equals new. I think you can say new, deleted, changed and changed for status. So we can describe changes like that one fairly simply. So that's using standard ditter. Gets slightly more complicated when you want to do something like represent change to an attribute. This is a request that we see quite often. People want to know about the href changing. And so two inputs, the top two paragraphs. How do we represent the change? Well, there's a solution at the bottom. What you can do, you can't say, there's no way of using the status attribute to represent the change in the href directly, but if you push the change up a level in the tree, what you can do is you can use two hrefs and get both of the hrefs, so when you move across the possibly red and green styled XML specifications there, you'll see two different tooltips with the information you need. It's not ideal, and this is one of the things that perhaps the W3C community group can address by saying, are good ways of supporting attribute change. Okay. Final example, again from ditter. We're going to look at I took this example from the ditter 1.1 language reference manual, and it talks about two-wheeled bicycles. I think there's a bit of redundancy there. So try and correct it. And we tried the obvious way, the way I presented earlier, of using PH, but we can't do that because the content model for alt doesn't allow us to put that PH in. So, okay, scratch that idea. Let's move on to the next way. We talked about propagating change upwards like we did with xref. Can we do it with alt? No, we can't, because image only allows you to have one alt child. So you don't have repetition of that child. So if you go push it up one level further, you can use the technique at the bottom of the slide to finally get away with something. It's not ideal, and so this is one of the things we'd like to see change. Now, luckily, that was ditter 1.1, and they managed to fix that problem in ditter 1.2. But it gives you a flavour of the sort of issues that we see in grammars that make it difficult to describe change. So we like the built-in support in languages. It's a useful thing because the tooling typically supports it. Ditter might have good reasons for saying you only have a single topic or a single short description or something, but in general would suggest people think about having repetition. Unless you've got a good reason not to put it in, would say put in those stars and the pluses in your DTDs, your schemas, to allow us to represent change, because it is quite helpful. Okay, so final thing is format flattening. So this is a technique we use to deal with mixed content. People use wrap markup around bowls, spans around chunks of text, and they don't really see, when you talk to document users, you don't really get very far when you say, oh, but you've moved that up and down the hierarchy and it's in a different place. What we need to do is we need to give them a description at the word level of how the document has changed. They're interested in words, they're less interested in formatting, they're less interested in XML hierarchy, inline markup. So we need to kind of do some flattening, removing hierarchy, comparing sequences of words. So I'll skip a few slides so we've got a bit of time for questions. So we do a kind of flattening like that. And when we come to process it, we have some problems. Now, this is an example which isn't in the paper, but we found recently in something called ISO STS, which is a derivative of the NLM JATS format used by ISO to describe standards. These are two TD table cells, and we were asked to compare them. And so we used our previous format flattening approach and algorithms, flattened all of the formatting out of them, tried to compare the words, align the words, and reconstruct, as best we can, a sensible formatting hierarchy after we've done the comparison. And the result we have looked like this. And what we ended up doing is we ended up putting a P, a block level element, inside an italic, which was an inline element, and it was invalid. And if you look, we scratched our heads and thinking, okay, we've had many problems with things like Ditto and DocBook with this code, this algorithm, what went wrong. We went to the document reference manual and we found this, we found P inside the content model of a TD. And we hit a problem which has been known about for quite a few years in, I think in the SGML world, the idea of pernicious mixed content where you have both inline and mixed things, both as children at the same point in your schema and your DTD. And so we'd say avoid that, please. We now have to go back and we did a quick fix. We're now going to have to do more work on getting algorithms that can deal with the horrors of pernicious mixed content, which date back 10 years. If you do a search for that, you'll see that it was the first hit you might get was probably Norman Walsh's book on DocBook, the Definitive Guide version 4. And you'll see some examples of why that's such a horror in parsing. It's also a horror for us in format reconstruction and the algorithms we use to kind of get that. So it's, I think, there's more things there that are in the paper to have a read. So, any questions?
Going back to this thing about change, one of the things that the authors commonly do is put changes across structural boundaries. So they will, and also formatting, they will start in the middle of a paragraph and,
yes,
and wipe that from the next paragraph. And it's something where Word, in some ways, does it better. It puts a marker at the beginning of the change and a marker at the end of the change. So your techniques for dealing with it will break down at that point.
Yeah, editors understand what the users do. Comparison algorithm can only guess. We'll know that perhaps the middle paragraph was deleted and some of the previous paragraph was deleted in that case, but we don't know that it was the same operation that did it. So track change mechanisms, if it's turned on and used in an editor, can give you a better result than a comparison algorithm can kind of deduce after the fact. That's true. But we can both use the same representation, the same tooling for accepting and rejecting and displaying the changes. So that's where we see a benefit in improving those. One of the things we'd like to improve is things like the cows table, the calls attribute. So when you delete a column, that could be a single atomic operation that could be reversible. That requires enhancing those kind of formats, and that will benefit both editor users and us, because we can represent it in that way, and editors can record things like column deletion better.
Could I just add one thing to that? Sorry, as a sort of author of the paper, hiding in the corner here, that specific area of people picking one particular area and going to another and then just deleting it in an editor is something that we're addressing specifically in the W3C track change group, because people do want that, because that is what they did and that's what they expect to see. But in XML terms, it's horribly complicated to represent. It can be represented, but it is quite complicated. So it is a specific, rather nasty use case that we've got in the track change area.
I mean, in fact, it absolutely goes to the fundamentals of XML, because it's about overlapping hierarchies.
Yeah.
Yes, absolutely.
Which is what the format flattening and reconstruction problem we do is as well.
Yeah.
Any further questions for Nigel? Yes?
The questions wouldn't be. I think I've done these things before as well. It's difficulties as you're saying, because XML and hierarchy you can't kind of start and end easily. Just notice some of the applications we've used, like even our text editor, it kind of doesn't put it into our schema. It does it in the application layer, the track change presentation and stuff, or how it reads the markup for the track change. And then another tool they use starts and processing instructions.
Yes, different tools use different approaches. Oxygen uses processing instructions, so does XMetal. Our text editor has, I think, 8 ticked namespaces and puts elements in a namespace to do it. So there's different approaches. I think what we'd like to see is we'd like to see improvements in the representational capability, so cross-hierarchy, attributes, some of these improvements, but also degree of standardization would be useful as well.
Okay. Thanks, Michael.